Hey Geometry Foundations 9, this is Mr. Zickler, and today we're going to be learning about transversals. First, let's talk about the necessary vocabulary. A plane is a flat surface. I say like because the surface doesn't have to actually exist. It can be imaginary. So for instance, a tabletop or a whiteboard could represent a plane. Like lines, planes go on forever. So a tabletop or a whiteboard, which has edges, is really only a small part of the plane. Try to imagine a flat tabletop, and then imagine it expands and becomes miles wide and miles deep. Not deep like this, but miles going in all directions. Next, parallel lines. For lines to be parallel, they have to lie in the same plane. For instance, if you drew two lines on a whiteboard, those lines would lie in the same plane. Those arrows at the ends show that those lines theoretically go on forever. We've just drawn a small part of them. But that's not all it takes for two lines to be parallel. The two lines also have to, if you were to imagine them going in both directions forever, never cross one another. You can see that if this line continued going on like it is, it would cross the green line. So those two lines are not parallel. I'm now going to draw two parallel lines. Not quite, pretty close. Let me try that one again. Pretty good. Those two lines, if they were to go on in both directions forever, would never intersect, as long as I got that exactly right. We see parallel lines all the time. For instance, the line here at the end of this at the edge of this whiteboard is parallel to this line at the edge of this whiteboard. And these two black edges are parallel to each other as well. Transversal is our next vocab term. Many of you already knew about planes and parallel lines, but did you know about transversals? A transversal is a line that cuts through or intersects two parallel lines, like this. When a transversal intersects two parallel lines, we can predict a lot of things about the angles that get produced. Angles. When two lines intersect or come together, they always form an angle. So for instance, here's a line, and here's another line, and they come together or intersect right here at this point, and they form an angle. When we want to talk about an angle, we draw a little curve that connects the lines like this. That shows that we're talking about this angle. We might call it angle A, or we might say that angle A has a measure of 120 degrees, or whatever it happens to be. When we draw two parallel lines and a transversal, we get a certain number of angles all the time. Take a moment and see if you can count all of the angles that are produced in my drawing here. All right, what number did you come up with? If you came up with the number 8, you were right. Here's an angle here. Here's an angle here. There's an angle here. And another angle here. We've got an angle here. And an angle here. We've got an angle here. And an angle here. We get 8 angles when we draw two parallel lines, and a transversal. That was kind of a mess at that point. Too much to look at. So we'll draw another set. Congruent is our next vocab term, and congruent angles are the same as each other. It doesn't matter how long the line segments are that are making up the angle, just the measure of the angle. For instance, if I have a square table, which I do here, you can see that that square table is nestled into the corner of this basement room here. If I have a square table, I can put it snug into a square corner in my room because the angles of the table and the room are congruent. It doesn't matter that the table is smaller than the room. The table angle and the wall angles are still the same or congruent. Vertical angles is the next term that we're going to cover in this video, and then from there on, the rest of the vocab is going to be covered by the Desmos activity. So vertical angles are what you get when you draw two lines that intersect. Like that. We would say that this angle here is vertical to this angle here. Now we usually use the word vertical to mean straight up and down. That's not what it means in this case, although you can see that this angle is above this angle. We also say that this angle here is vertical to this angle here. When we have vertical angles, they are always congruent. So for instance, because this angle here is vertical to this angle here, the measure of this angle is going to be equal to the measure of this angle. Now they're not equal to these ones that are next to it, but you can say that this angle here is vertical to this angle here, and they are therefore congruent. So this angle is exactly the same as this angle. The Desmos assignment will walk you through a few more concepts. Please do all 15 slides. I'm making this due on Monday to allow for any tech glitches or problems with accounts to be worked out, but it would be best to finish it now if you can. As always, contact me with any questions and problems, and have a great day.